Why did N-rays gain traction as unsubstantiated claims? Imagine hearing about a new kind of radiation that could change physics forever. That's what happened with N-rays, a story full of scientific excitement and confusion. It all started with a respected French physicist named Prosper-René Blodleau. He was known for his work on electromagnetic radiation, which made his claims seem credible. When Blodleau announced he had discovered a new type of radiation, many scientists paid close attention. The time was right because recent discoveries like X-rays and radioactivity had everyone curious about unseen forms of energy. Blodleau described N-rays as emitted by heated metals and the sun, which sounded plausible at the time. His experiments involved watching tiny changes in the brightness of sparks or glowing materials, which he believed were caused by N-rays. Several scientists tried to replicate his results, and some reported success, adding to the excitement. Photographs were also presented showing differences in light sources when exposed to N-rays, making the claims seem more real. The combination of Blodleau's reputation, some initial positive results, and visual evidence helped N-rays gain popularity. But the problem was that these observations were very subtle and based on visual impressions. They were easy to be influenced by suggestion or bias, especially since the effects were hard to measure objectively. The turning point came when American physicist Robert W. Wood visited Blodleau's lab. He secretly removed a key part of the apparatus, yet Blodleau still insisted he saw N-rays. This showed the effects were illusions, not real radiation. Further investigations revealed that the photographic differences were caused by inconsistent film development, not any new rays. This episode highlights how social factors like a scientist's reputation and the desire for discovery can lead to false beliefs. The properties attributed to N-rays were vague and contradictory, making them easy to dismiss once proper tests were done. Blodleau's case is now seen as an example of pathological science, where wishful thinking and small experimental errors lead scientists astray. It's a story that fits perfectly into the world of strange experiments and quirky results. It shows how even brilliant scientists can be misled by their own expectations, and how science corrects itself over time. The N-ray story reminds us that skepticism, objective measurement, and replication are essential in scientific work. It's a fascinating reminder of how science is a human pursuit, full of surprises and lessons.